Our skies have always been full of wonders. Astronomers have been trying to answer so many questions for thousands of years. Now with the advancement in technology, we have been able to see into the universe's past. With the discovery of a multitude of galaxies, it is estimated there are 2 trillion galaxies in the universe. We have now begun our true search for life in our universe, and outside of our solar system. The James Webb Space Telescope has opened up many new horizons for astronomers. In today's episode, we will cover the top 5 James Webb Telescope pictures to date. Number 5. The Carina Nebula. The Carina Nebula, or NGC 3372, lies 8,500 light-years from Earth. It was first discovered in 1752 by Nicolas Louis de Lacaille, and has been studied extensively since then. It is so large that it even contains its own nebulas, and one of the brightest stars we know of, named Eta Carina. Eta Carina is contained within a nebula known as the Homunculus Nebula. It is believed to have been ejected in an enormous outburst in 1841, which briefly made Eta Carina the second brightest star in our sky. The Carina Nebula also contains what is referred to as the Mystic Mountain, a dust gas pillar in the nebula that was photographed by Hubble on its 20th anniversary. The pillar measures 3 light-years in height, harbors newborn stars inside the pillar, and fires off gas jets that stream from its towering peaks. HD 93250 is one of the brightest stars contained in the Carina Nebula, only 7.5 arc-minutes from Eta Carina. It is considered to be a member of the same loose open cluster of stars, Trumpler 16. Although it appears closer to the more compact star cluster, Trumpler 14. Number 4. The Cartwheel Galaxy. This lenticular and ring galaxy lies about 500 million light-years away from Earth, in the constellation Sculptor. An estimation of the galaxy's span is 150,000 light-years, which is slightly smaller than the well-known Andromeda galaxy. It was discovered by the renowned astronomer Fritz Zwicky in 1941. Zwicky considered his discovery to be one of the most complicated structures ever discovered in space. A collision with another galaxy caused the bullseye look, and the collision violently sent shockwaves through the galaxy, which triggered many star formations. Optical data from Hubble shows where this collision may have triggered the star formations, and with further studies from the James Webb Telescope, we may soon know this for sure. The Large Cartwheel is the dominant member of the Cartwheel Galaxy group, which consists of 4 physically associated spiral galaxies. Number 3. Stephans Quintet. This beautiful mosaic formation of galaxies is a composite of near and mid-infrared data. It is Webb's largest image to date. Covering an area of the sky 1/5 of the Moon's diameter, it contains more than 150 million pixels, and is constructed from about 1,000 image files. This group of galaxies is one of the first compact galaxy groups ever discovered. The group, which is visible in the Pegasus constellation, was discovered by Edward Stephan in 1877, at the Marseille Observatory in Marseille, France. It lies at a distance of approximately 280 million light-years from Earth. The relative proximity of Stephans Quintet makes the group a frequent target of studies. The galaxies provide scientists with invaluable insights into galaxy evolution, and how interacting galaxies trigger star formation. The central pair of galaxies have started to merge with each other, and the collision has drawn out long tails of stars from each galaxy, and has triggered massive bursts of star formation. Number 2. James Webb Deep Field. NASA's James Webb Space Telescope has delivered the deepest and sharpest infrared image of the distant universe to date. Webb's first deep field image is Galaxy Cluster, SMACS, 0723, as it appeared 4 billion years ago. It is teeming with thousands of galaxies, and includes the faintest objects ever observed in the infrared. Webb's image is approximately the size of a grain of sand, held at arm's length, a tiny sliver of the vast universe. The combined mass of this galaxy cluster acts as a gravitational lens, magnifying more distant galaxies, including some seen when the universe was less than a billion years old. This deep field, taken by Webb's near-infrared camera, is a composite made from images at different wavelengths, totaling 12.5 hours to compile the final image. In comparison, it would take Hubble weeks to achieve imaging this great. In addition to taking images, Webb also obtained spectra data that revealed objects' physical and chemical properties. This will help researchers identify many more details about distant galaxies in this field. Webb's near-infrared spectrograph observed 48 individual galaxies at the same time, a new technology used for the first time in space. Number 1. Earendel. Earendel is the most distant star ever observed to date. It lies an astonishing 28 billion light-years from Earth. The star was detectable due to gravitational lensing caused by the presence of a galaxy cluster between it and the Earth, amplifying the light from the star. First discovered by the Hubble telescope on March 30, 2022, it has now been captured by the Webb telescope at much finer detail. With further spectral analysis studies from the Webb telescope, astronomers believe they will be able to detect elements heavier than hydrogen and helium. By studying Earendel's stellar spectra, it will also help determine whether it is actually a single star, or a star cluster. The light detected from Earendel was emitted 900 million years after the Big Bang. With its determined redshift of 6.2, the light from Earendel reached Earth 12.9 billion years later. When the starlight from Earendel was emitted, the star was only 4 billion light-years away from what became the Milky Way galaxy. As the universe expanded during the 12.9 billion years that it took for the light to reach Earth, the star would now be 28 billion light-years away. The goals set out for the Webb telescope can be accomplished effectively by observation, in near-infrared light, rather than light in the visible part of the spectrum. For this reason, Webb's instruments do not measure visible or ultraviolet light like the Hubble telescope, but will have a much greater capacity to perform infrared astronomy. This will open the door for astronomers on discovering habitable planets, and understanding galaxy formations and evolution, as well as star formations and planet formations. Webb will also search for light from the first stars and galaxies that formed after the Big Bang. The future discoveries the Webb telescope will make will be historical, and will change how we look at our universe, answering many questions, and bringing forward many more. Thank you for watching this episode. Please like and subscribe for more content like this.